So, in the last video, I talked about problems that arise as a result of order effects. In this video, we'll talk about how to deal with those issues, how to resolve the order effect outcome. So, there are two solutions. One is counterbalancing, and counterbalancing means that you change the order each time you do it, so that you can take away the effect of order in statistics. So if order becomes a second factor, like in the pre-post test design, then if order interacts with the other factor, then you know you have an order effect. And so one solution to that, or the way to find out if that's there, is to have a complete counterbalancing effect. A second way to do it is through partial randomization via Latin squares, which I'll describe that in more detail in a minute. And the third is through partially randomization through a computer. So let's say you have 5 conditions that someone's going to engage in, and you know that's a 5 factorial number of options that you've got there. It's too many to actually have enough subjects in each group to have complete counterbalancing. So you just let the computer put it whatever order it is, and therefore whatever effect there is of order is randomized completely across your samples. You can look at order there. Maybe you can look at first and last presentations. It's not as easy to look at order effects because you don't have complete counterbalancing, but computers, the way we almost are always doing it now. And the other class option is just time to let the effect, whatever fatigue, practice, contrast effect, just dissipate by giving a little time. So there's a graphical representation of counterbalancing. You've got your participants who are randomly assigned to either have order 1 or order 2. Now you can see that order becomes a factor in and of itself. And then the IV is the within subject. So you've got a two-way design to order by factor, whatever that may be. To do Latin squares, in this group, in this example, they're imagining 4 conditions. And so you randomly assign 1 order. You just get your 4 and you randomly order the first group of 4. And then you get, it's square, so you get 4 conditions would yield 4 outcomes. And then because the first one is randomized, then to randomize the rest of them, you just add 1, you increase the level of the condition for each one below it. So if you look at A, B, D, C as the top row, A, B, D, C is the top row, and then the next row, add 1 letter. It's B, C, D, B, C, A, D, and then C, D, B, A, and D, A, C, B. And so now we've got 4 completely different orders. We can look at an order effect for Latin squares, and it's always systematic. It's reduced the total cost of the order effect. We only need to get 4 between subject groups rather than 16. We only have 4. It's not complete, but it's better. All right, so this other way to deal with repeated measures design issues, or because you can't do a manipulation, is a matched pairs design. Now, we use the same statistic for matched pairs design as we do for repeated design. It's the paired samples t-test. But in a matched pairs design, the pairs are actually different people that have been matched on some third characteristic. So you've got the manipulation, and they either get A or B in the manipulation. And let's say you have 10, let's say you have 20 people in your sample. You divide them in half, so you got 10 in each group. And let's say that the outcome, let's say it's that we're manipulating whether a tie impacts performance, and we want to know whether or not that happens, but we can't have it repeated measures because then you'll know that the tie was there. So half of you are assigned to the other group, and half of you assigned to this group because I'm wearing the tie. Now, in order to reduce variability, we will rank order you on maybe prior GPA. I mean, the highest GPA match the highest GPA on down, so that the variability of the third variable, which we know predicts outcomes, people with higher GPA do better in stats methods. If that other variable can remove variability from the sample, we treat those matched pairs as though they're repeated measures, even though in fact they're different people. That match pairs design. You and I are not going to do many match pairs designs, but it's important to know that that tool's out there. So how do you decide whether or not you want to do an independent group sample or repeated measures design, or a between or repeated design? Well, the first thing is, can order be controlled? If order can be controlled and it's not a problem, do repeated because it's cheaper and you have more power. Is subject variability challenging? Then maybe you want to do repeated. Right? If there's going to be a lot of subject variability, maybe you want to control it. Conversely, if you can't control the order effects, if there's just too much of a demand characteristic, let's say you're looking at something about prejudice or racism or sexism, and chances are repeated measures design is going to out you for the question you're asking. And it doesn't matter how you do order effects, you're still outed. And so then you'd have to do a between. Remember, repeated is always more powerful, but it doesn't mean it's always possible. So, basic design choices, between or within. The design dictates the statistics. We can address design issues with the Solomon four-group design. Randomization, counterbalancing.